Well, up next is a conversation about how identity is evolving. And here to speak with us about this is Michael Sena of 3Box Labs and the Ceramic Network. Michael, take it away.
Thanks, David. All right, so I see my slides up here. Cool. So I think this next block is going to be about identity for about an hour. So I have a 30-minute talk now, and this is followed up right after this with a panel on decentralized identity. So if it's interesting to you, I encourage you to hang out, stay around, ask questions, and engage the panel. Cool. So here we're going to talk about decentralized identity. Basically go through a little brief history lesson because the decentralized web hasn't been around for that long. And we'll talk about where we're going next. I feel like decentralized identity is one of those topics that seems to come in and out of fashion every year or two. And it seems like it's back on the uptick now as developers sort of are beginning to think about how to create decentralized applications that can actually rival what's possible in Web 2. And we're sort of beginning to move beyond just the let's put a thin interface on a smart contract and instead thinking about how can we deliver great experiences. And cool. And so who am I? I'm currently a co-founder of 3Box Labs, and we're a software company. We've previously made the 3Box SDK, which is the most widely used identity system in Ethereum today. We have over 40,000 identities and over 200,000 connected databases. 3Box Labs is in the process of, as we mentioned in opening ceremony, sunsetting 3Box, and now we're beginning to work on Ceramic Network and the IDX standard. And together, these pieces really can deliver a complete solution to decentralized identity and sort of fill a lot of the gaps that have been lingering for the last 5 years. Previously, I was co-founder of Uport. It was the first self-sovereign identity data system on Ethereum. We founded that in early 2016. While I was at Uport, we were a founding member of the Decentralized Identity Foundation, along with Microsoft and a couple others, and we were early contributors to the DID spec v0. And we'll talk a bit more about DIDs, but they're basically the W3C standard for decentralized identifiers. And you can find me on Twitter and email. So let's dive in. So I won't read through all of this, but basically the word decentralized identity is so convoluted. So we're going to start out by walking through some definitions and just setting some common understanding. Then we'll sort of go into the main problems that need to be solved, previous approaches, and then look ahead. So kicking off, an identifier. It is as it sounds. It's a unique identifier, and it can be globally or locally unique. So we're not talking about specifically decentralized identity, just digital identity in general. Next, authentication is literally just demonstrating that you can control an identifier. And this obviously happens different ways if you're using a server-based application or if you're using a Web3-based application. Information in this context is just data attributable to an identifier. And discovery is the method used to look up information. And silos, these are obviously bad. So an identity is basically just the collection of all data associated with a unique identifier. And as we said, this unique identifier can be locally unique or globally unique. In the case of decentralized networks, they're globally unique. In the case of servers, they're locally unique. So it kind of, the same definition applies to both. And when we frame identity this way, it's just identifier plus data, you can really sort of bundle all of these other concepts of identity under it. So there's proof of humanity systems, anti-Sybil systems, like everyone talks about digital driver's licenses, or verifiable claims and selective disclosure and pseudonymity and all these other terms, but they're all forms of data or not, or the absence of data. And you can, and when we're thinking about constructing identity systems, we shouldn't build our future on any one particular implementation. Like identity is more like a framework and an abstraction And depending on the use case of the application, that's how you want to plug in certain kinds of data. But the identity protocol, the foundational layer, should not be opinionated. It's more like, how do we map data to an identifier? And then whatever types of data are suitable for your application, you want to be able to plug in. And so that's sort of the starting basis. And this definition holds true of identity, whether you're thinking of people, in the town square, like prehistoric, pre-internet times, where people were, their unique identifier was their face. And it was a local unique identifier, their face, their name, and the words they spoke and the things they did were the data they were generating. And that sort of was the identity system. It was a local, in-memory identity system. And if you sort of fast forward to Web3 networks, you have an example being a public key controlled by a private key, and that public key is doing transactions on a blockchain, and the transactions and the payloads it's signing are the data that's associated with it. So it's all kind of the same. And when we think about authentication and its role in digital identity, it's really all about allowing others to verify that the rightful owner of an identity is the one creating, and in some cases also accessing the data. And so, like in Meatspace, like I said, people see you physically say or do something, and that's, their observation of you becomes the authentication. If they hear something from gossip that you did something, maybe they're aware of it, but they really can't authenticate it. And so they're really just making a judgment. On Web 2 platforms, this obviously happens the way we all know with servers. So, you sign in an email and password, you get a session token, and with every request you make to the server, you send along a session token, and that's how they attribute the data to you. But in Web3 networks, it really happens using cryptographic signatures. So the notion of authentication is not authenticating into something. It's more just like proving that I own this key, and everything happens client-side in a completely serverless way. And that's how it's sort of flipped. There's no like communication between client and the server. It's rather just all client-side. And with identity, in every model of identity, there's always this problem, which I've called the known universe problem. Can also be called the problem of silos, where another person, entity, or computer's understanding of you is limited to the data that they already know about you, or that they can easily discover about you. And, in Web 2, this data is stored on a server, and it can only ever be accessed by those who can get into the server. That's, the application admins, myself, if they don't, censor me from the server, and others, depending on which data is meant to be publicly consumable within that platform. And in Web 3, you really have this thing, like I said, where data is signed by some public key. It's signed by the private key, but it's associated to the public key. And the information can really be stored anywhere, because in Web 3, there's not one server. Different apps can store data in different places. Maybe some apps are storing data on IPFS. Some apps are storing data in Textile. Some apps are letting users interact with the blockchain. And as it stands, all of those networks use different keys today. So you really have different identities for every single Web3 network. And there's no unified way to discover this data. So actually, as we move from Web 2 to Web 3, we haven't yet built out the right infrastructure to deliver on the Web 3 vision of user-centric data discovery and information portability and all the good things that we love about Web 3. We just don't have the infrastructure yet because we haven't solved the identifier problem. And we already talked a bit about this, but just to recap, so Web 2 server-based identity systems, if we look at what developers are doing today, we can kind of see what's missing in our stack. And so, in a server, a user has what I'm calling a locally unique identifier. and it's usually related to their username or email, and it's locally unique because it's only local to that server. That identifier is not persistent anywhere beyond that, unless you're sort of using an OAuth system, in which case it's more like it's siloed in that server, but others get permission to it. And an example of like if you're building an application and adding identity to it, if you're building, you're using some kind of relational database, say SQL, and you likely have a user table. It stores all your user IDs, and then it maps them to other data sources. So you have other application data like likes or tweets or blog posts or follow lists in all these other databases, and they're grouped by category or type. So it's like all people that follow all other people in a database, if that's not in a graph. But you might be like all the blog posts in this database. It's not user-centric. And you're using this user table to build all those mappings. You can look things up by the user. And you use foreign keys to build relationships between these databases. So in your blog post database and your user table database, they're connected by foreign keys that can point you in both directions. And discovery of all of this information is obviously limited. But in Web3, we have crypto identity systems. And we'll talk about some of the implementations that we've seen over the years. And starting with the most basic and simple, and moving to more advanced but more powerful solutions. And so we'll start with externally owned accounts. So public keys as identifiers. This is like the most basic, where you have, it's not even a one-to-one mapping, it's just the public key is the identifier. And everything signed by the private key is associated to that identity. And this is like the whole concept of like Web3 is all built on the premise of authenticated data. Like almost whatever Web3 network you use, there's some kind of a key system, and depending on wallet implementation, like those keys have to be able to perform signatures, whether the user holds them or they're custodied in some way. The system still works the same. And this system is good at what it's good at, but I wouldn't really call it an identity system. And what that means is it's good because it's simple. They're already supported by all blockchain wallets, which you go to any wallet today, you have a key pair. And it's good and fine for on-network transactions where you have this key. It is to provide you access to transact in this decentralized network. Of course, it's good for that. But where they don't really qualify as identities is because the management key, so what I'm calling the private key, the signing key, and the encryption key are all the same. And I'm not going to go into too much detail on that in here, but there are many published studies and known vulnerabilities that can be exposed when you do this. It's not secure. You can never rotate that key. So if anything ever gets compromised, you're losing your entire identity. And key management is super brittle. So if it's just a key pair, you don't really have some of the advanced functionality that you might have. And additionally, they're not really good for anything not on the network because they're made to do things on the network. And second, is this supposed to be second? Let's do this one next. So smart contracts as identifiers. And this has been around since mid-2016. When I was at Uport, we won DevCon 2 in Shanghai because we demonstrated the ability to deploy a smart contract as an identity and use a set of friends called social recovery to reinstate your ownership of that contract in case you lost your key. And so that notion of social recovery isn't new. And smart contracts are pretty great. I don't actually really think they're super great for user identities, but they are good for some things. So they're good for on-network transactions controlled by a set of keys rather than by one key. Whether that's holding funds and transacting funds, or interacting with dApps, or interacting with other contracts. You use the message.sender to forward all sort of transactions through that single on-chain entity. And obviously it gives you more robust key management options. Some drawbacks are that it's really expensive now. I think, and this has been why these haven't taken off more, even just as like being built into wallets for fund management. And additionally, identity is still siloed to the network, because you can really only control a smart contract with EOAs and other accounts from that network. You can't like plug in, I can't authenticate an Ethereum smart contract with my Near wallet. And so they don't really work as universal cross-platform identifiers. They sort of are good for an inter or intra-platform identifier, if that makes any sense. There are other deficiencies here, but I think we can kind of skip ahead a little bit. We've also seen people beginning to call domains identifiers. They do have some good properties to identity. I would stop short of calling them an identity system, in the same way that I would stop short of calling DNS an identity system. What they do is they resolve a human readable name to a machine readable address, and that's the core function of DNS. And sure, you can put things in the TXT records, and like sure, you can use it however you want, but at the end of the day, it's really good at addressing a machine readable thing with a human readable name. It's good for naming. Some of the drawbacks are registration and transaction fees, and some are permanent. Some fees are recurring, and so the fact that you can lose your identifier is not a desirable property for a persistent identity system. Also, the fact of name squatting and all of these other things that are sort of like known bad practices in Web 2. Like you normally sort of try to use a string of some kind and not use like a human readable name, because you're more likely to get collisions or competition, and you want to keep the identifier like abstract and behind the scenes, in the same way that you're keeping like your IP address abstract and behind the scenes. And names can change. Domain names are transferable. If you're actually using the domain name as the source of truth for an identity, it shouldn't be transferable. Like that's a flaw, not a feature. And it supports key types from Ethereum, and it's still a silo within the network. And lastly, in the same way that you could store anything in a TXT record or at a well-known URL path, there's no standard for interface for data. Like there's no defined schemas, there's no defined things. So like you're just interacting with arbitrary blobs in a TXT record. Like so it's not really, that's the reason why DNS hasn't really been used for user data management in the same way. And you still always have to go through the process of registering. So really what the next evolution in Web3 has been is really this movement towards decentralized identifiers. And I say movement towards because we've been working on some of these things for a really long time. There are now over 60 implementations of the DID spec, and there's now an EIP on Ethereum for implementing a DID interface for signing and encrypting data over the JSON RPC in Ethereum, which can also be implemented by any other wallet on any other chain. But DIDs are really a way to go from a decentralized identifier, a globally unique identifier, URN, and you resolve a document. And that document contains at a minimum, a set of public keys used for signing and encryption. And so basically, like, it allows you to, in the same way that you can just use the raw key pair to do this, it actually separates them into multiple functions. And as I mentioned, it's supported by the W3C Microsoft diff. It supports many key types. You can just keep throwing more key types in there. Depending on the implementation of DID, because it's a very lightweight spec, there's different ways it can be handled. Like some just derive a DID document from your public key, in which case, it's pretty inflexible and doesn't have all these capabilities. While others, like the 3ID did method on Ceramic, gives you a mutable did document where you can rotate keys in there and you can change which keys are authorized to sign on your behalf, all while securely managing that rotation in a strictly ordered, consensus-driven way. And it's just a better way to sign and encrypt data. Now, in the W3C, there's the DID spec is fairly large but flexible, and there's many ways you can use it. There's not like one way you have to use DIDs, but they're a much better way to represent an identifier rather than an account or an authentication method. And really, we like to think about now is all of these blockchain wallets can directly authenticate transactions on their local networks, but they can also authenticate the seed of the DID and then allow that DID to interact with anything else that's not on chain. And so with this model, you at least in the cross-chain implementations of DID like 3ID, you begin to have this persistent identifier for interacting with every other service. And then you have the chains from each blockchain or each Web3 technology, the wallet keys from them, able to control that identifier. That way, it delivers on some of the promises of user data portability because, as we said in the beginning, an identity is a UID plus data. And if you can map your blockchain wallets to that UID, you can, through the graph or any other indexing service, look at all the transaction history, and that's still there. But you map them to a DID, which then use that DID to sign and encrypt all other data that's kept anywhere else. And you have a nicely unified type of a system. And the last piece I'll talk about is discovery. And obviously, Web 2 doesn't have this problem because, like I said, there's a user table, and all that data is just neatly controlled in a central server, and one application is normally doing the read-write access. So, the app knows where it's storing its data and how it's storing its data. So discoverability is not really a problem. But on Web3, user data discovery is really fragmented because, as I mentioned, there are many different ways that it can be done depending on the application architecture and design. If you have just accounts that are interacting with the blockchain, and then you have some other app like Ethereum, Near, Polkadot, you have some other apps that are just interacting with IPFS or just Textile. And each of these applications has their own data model and place they're storing data and way they're managing keys and way they're setting up accounts. And so there's no single place on like a server where I can go to discover all of the user's data from across all of these apps. And that's really been a barrier to adoption of decentralized identity, and why one of the reasons why it hasn't been a reality is because each of these platforms is using different keys and different data models, and there's no way to tie them all together in a semantically meaningful way. And so without this standard way to go from a cross-platform, cross-key identifier like a DID to various pieces of data stored all over the web, generated from all different apps, we will never be able to realize the vision of an open internet. Now, some people are of the opinion that, like some in the W3C or in diff, that there's this notion of an identity server, which they call an agent or a hub, and a user will pay someone like Microsoft to run a hub, and every app will just write to that single hub. and discovery of data will be done in the hub, and indexing is done in the hub, and that doesn't seem decentralized at all to me. It seems like you have a decentralized identifier, and then you have a centralized server that is running not all the data from one app, but all of your data from all apps. So that seems like a more, I don't know that that's the right way. And so what we need is a system for data indexing and discovery that is decentralized. So a decentralized identifier, a decentralized system of indexing and discovery that can tie into any type of data store. And so a path forward. It seems like the ideal architecture for Web3 apps is a platform-agnostic DID, controllable by any or many different key pairs, linkable to accounts and keys on any blockchain or Web3 tech, so you can resolve in any direction. It should be linkable to domain names and Web2 accounts as well, and can connect to any type of a data store, so developers aren't forced to use one data store or another. They can continue to build their apps using the stack of their choice. And when the data association shouldn't be associated by app, because that creates application silos again. So if we actually want to solve the problem, we should be like linking data to a user in a semantic way. So, saying this is the schema of data that I'm going to associate to the user, and then it points to a record which contains that data. And any app can use it. It's not like tied to one particular app. And if we move in that direction, we'll be much closer to this web of interoperability. In that way, if I'm querying this type of a thing, I don't have to worry about which app first created this data. It's more just like, what schema do I want, and can I get it? And you can represent a lot of data like this. And it's really important that there's also a standard developer interface and API for getting and setting. Like it shouldn't be complicated, and it shouldn't be implemented in many different ways across many different apps, because then we'll never collectively get to where we want to go. And so I'll quickly talk about IDX. This is what we're working on. We've obviously been building these types of systems since early 2016, and we've been in the market, and we've been asked 1,000,001 times from 1,000,001 people, like, different questions that led us down this path. But IDX is a cross-platform identity standard, and it really is built around this concept of an index that is a key value map, effectively, where keys are definitions, and they map to records, which are objects, and they're semantically meaningful. And those objects can either store data, like a profile, or it can store pointers to additional data stores, like maybe a blockchain registry, or maybe a server, or a textile data store, or a ceramic document. And so, or a proof that binds my DID to my Ethereum address. And so, if we can organize data this way, in a cross-platform way, not tied to any specific network, then it actually sort of serves the function in our applications as a user table would, except now it's not, collections of databases organized around topics, but rather it's a single user-centric mapping to all data stored anywhere. And here's how it works. I mean, it's pretty straightforward. Developer publishes a schema on Ceramic. They include the doc ID of that schema in their definition, which sort of creates the semantic meaning. That doc ID of that definition acts as a key in the index. And then when a user is interacting with an application, a record is created. And the doc ID of that record acts as a value in the index. So you have a doc ID to doc ID mapping, and that index is really lightweight. And it lets you eliminate users from your server, connect all these accounts together. You have the flexibility to use whatever data store you want. By adding your data to the index, you're making it discoverable and consumable in other applications. It lets you, search and import data from third-party applications, and all the while giving users control. And it's simple to use. And this is the direction that we have to head. I mean, if we decide that we don't want to go in the direction of giving users interoperable control of their information and actually bridging these Web3 networks now we'll start to be building ourselves in a direction where it becomes later impossible to do. So I think it's critical that we start thinking about these things now, because the more entrenched users get in these accounts and these networks, the harder it's going to be to undo. And I also don't think that we can succumb to the pressure of just throwing things on a server, because I don't think that's why any of us are here. So thank you.
Thank you, Michael. That was a fantastic conversation and an introduction to identity and how it's changed over time, and kind of where we are right now in 2021 with decentralized IDs. Love your approach.